Today's presentation, we have two great subjects, two really important subjects: permit required confined space entry and trench safety. These are some of the most dangerous things that you will do during your career, are getting into these two important areas for us to be able to do our job, to be able to provide the utilities to our local municipalities or districts, whoever, whatever organization you're working for. This is an important subject, and so we do it every year. This is one of those things, in addition to just driving every day, this is probably the most dangerous thing you'll do in your career, is getting into a confined space or a trench. And I know there's a few of you out there saying, oh yeah, you want to bet? Let me tell you a few things I've done out there. Well, hopefully not. Hopefully we have you being safe out there on the job. At the end of the day, the only person that can make the right decision when it comes to your safety is you. Your boss, your employer, they may have grand intentions, but at the end of the day, it's you that's going to do that. Hey, Mike, just a quick check there. It says sharing is paused. Are you seeing my screen okay? Picture of me?
Yep, I got you.
I don't know why why I've got that notification, but all right. Important subject. So let's dive right in. Whoops. Am I having trouble today? Well, you just wait until the end. Hopefully we don't ever get into a confined space like this. Let's do it right every time. I know people out there.
So now, Jason, I'm not seeing your advanced slide.
Let me see I'm going to stop my share and then start it back up. Let's see what happens. I don't know why that. You see my screen okay now?
Yeah.
Sharing is paused. Bring your shared window to the front. Well, you can see that okay? It's a guy testing a manhole.
I do see that, yeah.
Well, let me know if this doesn't work. So just a couple of sobering statistics there. Rescuers account for 60% of confined space fatalities. What the heck does that mean? Are these firefighters that are really bad at doing their job? They go out to rescue somebody and they end up dying on it? Sometimes, but the vast majority of these are coworkers. They might be a supervisor that sees their buddy go down, or a coworker, and hey, where's Joe? Well, he's down in that hole. Oh no. And we yell down there and we can't find him. And somebody runs down there because they want to save their buddy. And they have this delusion that they can throw a 200-pound man over their shoulders and carry him up a ladder in a hazardous atmosphere, and it just doesn't happen. So one of the important things that hopefully we'll learn out of this training is you got to protect yourself first. If somebody tips over, all I can do is dial 911 and do what I've got set up to rescue that person from outside. If I've got a team there, that's great. But I can't just throw it all aside and dive into that space. 65% of all confined space fatalities are due to a hazardous atmosphere, low oxygen, flammable, or toxic, something in those neighborhoods. 65% or 65% of confined space fatalities are simply due to that. What does that mean? That means that people aren't testing their air. That means that people aren't ventilating their spaces. Now, I'm going to talk to you about a lot of things today on permits and how we have to put those in place and rescue and all of that stuff. But there are two things. If you will test your space and ventilate your space, 65% of those fatalities will probably go away. Those are critical things that we have to do every time, and check those and be a fanatic about doing that, because that will save your life. A third of all the people that died in confined spaces were supervisors. Death is no respecter of persons when it comes to confined spaces. 25% of the spaces were toxic before entry. What the heck does that mean? Well, that means they went in when it was bad. There wasn't enough oxygen, or there was carbon monoxide, or there was something else in there that was bad. But I always like to look at statistics the opposite way. 75% of the time when we had a hazardous atmosphere fatality, it was okay when they went in, but something changed. What the heck does that mean? Well, that means something that we did, or something changed about the space. Many times we are our own worst enemies when it comes to confined spaces. We'll go in there and we'll start up a saw, we'll start up a generator, we'll open up the bottle of tetraethyl death, and we'll kill ourselves. I came upon a confined space near fatality. Could have been a fatal accident. Down in southern Utah, one time, one of our members had just had constructed a new water tank, and the trust was going to insure it. And part of what I do is I check out your facilities. We go and we walk through, we look for hazards, we look for things that could cause us to lose a property or have damage to a property. So I drive up to this water tank, and as I pull up, there's a vault, one of those big vaults that has two doors that open up. It's sitting open. There's a ladder sticking up out of it. And there are two guys, young guys, standing on the side of this vault with their hands on their knees, gasping for breath. And I just pulled right up to them. I said, "Guys, you all right?" And they're gasping for breath. They said, "We just about didn't get out of there," as they're gasping for breath. And so I take a couple of steps back away from the vault and try to figure out what's going on, and ask them what they were doing. As it turns out, this was just simple concrete box with a pipe that went through it, and it had a meter on this pipe. It was the main pipe going out of the water tank. And their boss, the contractor who had built the water tank, had told them, "Go into that vault and prep that pipe for paint and paint it. We don't want that pipe rusting because it's going to be exposed to some different environments there." So these two young kids, they were, maybe 18, maybe 20, just out of high school, climbed down into this vault, took a gallon of lacquer thinner and poured it all over this pipe, and started wire brushing it to clean it up, to prep it for paint. Well, they were almost overcome by the vapors from this lacquer thinner, and it was a bad situation. And their boss wasn't terribly concerned about it. Well, he was by the time I got through, because these two kids could have died that day. Unfortunately, we've had a confined space fatality here at the Trust. And that's something that's really important to me as a safety professional. Man, that is the essence of failure, is when we have somebody die. Now, I know I've got 500 plus organizations around the state, and I can't be everywhere all the time. But one of the reasons I do this class every year is because of how important this is. And we don't want this to happen to any of you out there. But the only way that we can prevent that is if you take it, internalize that, and make it your job to keep yourself safe around trenches and confined spaces. All right, let's move on. And Mike, tell me if this video is working okay.
We have sound, but you're no picture. So we're still on the manhole cover. So before you share, so try unsharing, starting your presentation in presenter mode, and then share that.
Well, I can't start in presenter mode.
It won't let you start in presenter mode and then share.
No. All right. Share that. Okay. Every time I'm doing that is sharing is pause. Bring your shared window to the front. How do I do that? I've never seen that window at all. Sorry, folks. How do I do that? Resume share. It is not allowing me to do that. Huh. All right. Well, let me try this. That video is not going to work. Can you see this screen okay anyway, Mike?
Yeah, I can see it. Okay.
I'm just wondering why that's. Oh, hold on. So you can see the screen okay. You can see that screen okay.
Yeah.
Okay. Well, I'm just going to do it like this. Apologize that it's not going to be the prettiest. Let me try something. I'm going to try one more time. Now, can you see it?
I can see it. Yeah.
Okay. Let's just.
We'll see what happens. But there you go. You advanced the slide and it went. So.
And maybe it has something to do with the videos. I don't know. I hate that when they change the settings on there. I've never had that happen. All right, guys, let's keep moving along. Think about the confined space that you get into most often. What does it look like? Is it a simple concrete box? Is it a PRV vault, meter vault? Is it a sewer manhole? What does it look like? Is there a space that scares you out there? Think about those things as we go into this material today. How do we go about dealing with that space to make sure it's safe? Especially that one out there that makes you nervous, that, hey, we found hydrogen sulfide there a number of times, et cetera, et cetera. Okay, so this is permit required confined space entry training. And we say, and we say on here, what is an entry? What does it take to be an entry into a confined space? And the answer is when any part of our body breaks the plane to get into that space, it's an entry. If I stick my hand into, maybe there's a valve that I can reach down into a permit required confined space, that's an entry as under OSHA's standard. Now, a lot of what we're going to train today has to do with OSHA because there's an OSHA standard. And you'll be expected to live up to that. Like I always say, though, OSHA is kind of the minimum standard. I could care less about OSHA. I care about you guys going home at the end of the day. So how do we do this right? Well, we're going to talk about OSHA and talk about what their requirements, because on this standard, OSHA standard is pretty darn good. Okay, so what's an entry? Any part of my body goes into a confined space, it is an entry. I reach my hand in and I turn that valve. That is an entry and should have a permit in place and everything else in place. And you say, oh, that's just silly. Well, it could simply be, there's a flammable atmosphere and I reach down in there and I cause a static electricity spark or whatever. I could blow myself up from that. There could be a toxic agent emanating out of that space. And there have been a number of people across the country who have been killed standing next to a manhole, not getting into it. They popped the lid and there was enough gas that came out that overcame them right there. So anytime we're dealing with a confined space, it's a big deal. And you say, well, what the heck's a confined space? Well, it is a space that's big enough to enter. I can physically get in there and get into that space. Now, it used to say, still does in the general industry standard, large enough to enter and do work. If you're under the construction standard, it doesn't say and do work. If you can get your body in, then it will potentially be a confined space. Has to satisfy these other two things. Has limited means of entry and egress. That means it's hard to get in or out of. I crawl through a manway. It's a manhole. I have to go up and down a ladder, whatever it may be. It's not opening a door and walking into a room. Even if that room is a closet, it's a small space. And it's not designed for continuous employee occupancy. You're not supposed to be in there all the time. Now, if it has ventilation and you can put a desk in there and work, well, it might be designed for continuous employee occupancy. All right, so that makes it a confined space. If it's big enough to get into, it's hard to get into, and it's not designed for me to be in there all the time, it's a confined space. But that's not a permit required confined space. So what does that take? Oh, here's some examples of this. There were always lots of arguments over what exactly is a confined space. And so OSHA, when they released their standard for the construction industry, they said, here's a list of examples of confined spaces: manholes, tanks, crawl spaces, pits, vaults, ducts, digesters, attics, chillers, bag houses, lift stations, silos are all potential confined spaces. So what does it take to be a permit required confined space? Where do all the standards come in? Well, it needs to have a hazard in it. It's a confined space that has a hazard. It contains or has the potential to contain a hazardous atmosphere. Well, that can be really simple. Some of these spaces could be a simple concrete box that maybe has a little bit of water, it's damp in there, and bacteria or other biological growth in there consume the oxygen in the space. It's not naturally well ventilated. And so it's a simple concrete box, but there's not enough oxygen in there to keep us alive. And this is one of the really common causes of confined space fatalities, because it doesn't look bad. There's just not enough oxygen in there to breathe. Or it could be one of the other causes of other hazardous atmospheres that we'll talk about in a second. It contains a material that has potential for engulfing an entrant. Water, sewage, grain in a silo, manure pits are confined spaces that are really nasty because you're engulfed. But water in a vault, water in a pit or something like that could engulf you. Has an internal configuration that could trap or asphyxiate an entrant. So something that I could get pinched or caught. You think of a asphyxiation where I could be crushed to the point where I couldn't breathe. That's what we're talking about there. Contains any other serious recognized serious safety or health hazard. What does that mean? Well, it could be open electrical, it could be fall hazards, you name it. There are a lot of things that would be a serious health hazard in a confined space. And some of those things are a lot worse inside of a confined space. Well, I can have an open electrical panel over on that wall 100 yards away, and I'm not too worried about it. But if I've got open electrical inside of a confined space where I've got no place to get away from it, then that's a lot more dangerous to me. Okay, so it's hard to get in. It's not designed for me to be in there, and it's hard to get it, and I can physically get into it. And then there's a hazard that makes it a permit required confined space. All right. So as an organization, you need to have a list of your confined spaces, and OSHA will give you a citation if you don't have this list. So you're saying, what? You mean I need to have a list of all of those sewer manholes that are out there, all of those PRV vaults and everything like that? And my answer is yes. You are required to have that. You can use your GIS system. You can use the inventory system to track what those are. If there are some particular hazards for those, you should also track that and have that list of what those spaces are, and then reference whatever the name is. It might be a number, it might be a code or a physical name that you put on it. Reference that on your permits. Okay. So we decide that we're going to go in permit required confined spaces. You don't have to, right? Your employer can make a decision that we're not going in there, but you got to stick with it if you decide that that's what you're going to do. But for most of us, that's not an option, right? We're public work organizations, and we make sure the water flows and the sewer flows and all of those utilities keep working. So we decide we're going to go in. We need to have a permit system. We have a written program that we put together. We have a written permit. We designate a competent person, somebody that understands the risks, the hazards, and has the authority to do something about those in our system. We have specific roles for our people. We designate a rescue, who's going to be doing rescue, and we ensure that they're trained appropriately for the type of spaces that we're getting in. And then we talk about hazardous atmospheres and how we're going to ventilate, how we're going to test, and all of those things and those other things. So let's talk just quickly. For permits, we need to have a written permit and we need to use it. Now, this permit, I've seen some places where they're like, yeah, our permit's good for a year. No, this is for each individual entry. And when you're done, you cancel the permit and we keep it. Let's put it in a binder, a folder, and we should be keeping those at least for a couple of years. But I would say I would keep at least 5 years of those. When OSHA shows up, I want to be able to show not only did we do it right yesterday, but we've been doing it right for a long time. So get off our back. We know what we're doing, and we're doing the right thing. Okay, so when it comes to a permit, OSHA has a standard permit, and I'll send out a packet with some various forms. A sample permit is one of those. So for everybody that registered for this class, I will send that out in email when I let you know that the video is up. You can use the OSHA standardized permit, or you can create your own. But be careful cutting out too much stuff. Look at what OSHA has there. Now you can make it really easy. Maybe we have a couple of PRV vaults that we get into all the time. That's where we're doing the majority of our confined space entry. Well, you can fill out a lot of the information minus the date and the time and stuff like that, but everything specific about the space, you can have a customized permit for those confined spaces. And so when you go in, all you got to do is circle it's this PRV vault that we're going into, and then start gathering your data specific to the entry there. But make sure that we have all of the information that would be relevant to that space. And so start with the OSHA permit. You can make it standardized for your spaces, but don't cut out too much stuff. We've got to have the stuff that will allow us to be safe. All right, I said we got to have a competent person. This comes from the construction standard, but I think, like I said, OSHA is kind of the base level of things. This is somebody that would understand what the hazards are of your confined space, of all the spaces that you have, and have the authority to do something about it. If we don't have a safe procedure, they have the authority to say, stop it. We're not going to go into this space. Or we get in and we find something's not as we thought it was. They have the authority to say, stop it, pull everybody out, and let's figure out how we do this safely. So designate a competent person for your organization. So if you're in a room with a bunch of people, everybody turn and look at the competent person on confined spaces. If you've got a confused look on your face, that's probably your first job today, when the training's done, is to go and ask the question, who's our competent person? And how do we ensure that we have somebody that has that level of training? Okay. Their jobs determine whether we have confined spaces, identify if they're permit spaces, and then look at our entry procedures. Are they appropriate? Look at alternatives to entry procedures, and make sure that we're following our program. Answer questions about a space. Then we're going to designate our entry team. Who are our people when it comes to getting into a space? And these are designated people. So we have authorized entrants. These are people who, like it says, are authorized to go into a space. You can't go into there unless your employer has said, yes, you are authorized to enter that. You've got to be trained, of course, to do that. They need to be able to use the equipment properly, be able to communicate with the attendant, which is the second role that we'll talk about. That's somebody who stays outside of the space at all times and then maintains communication with the entry team. So they need to be able to communicate. How do we do that? Well, it could be in the forms of physical, verbal communication right here. I can see them. I'm just down in a vault, and we can talk back and forth. If it's a bigger space, it may be radio communication. Some places radios won't work because we're way down in a tunnel. So there may be a different communication route that we'll have to use for that. An authorized entrant needs to alert the attendant of prohibited conditions, things that shouldn't happen in that confined space. Hey, my meter, the alarm's going off on my confined space meter. That's a prohibited condition. Get your butt out of there right now. And authorized entrance needs to get out of the space if necessary. If the attendant says, blows the horn and says, everybody evacuate now, that's what you need to do. We don't wait around to tighten that last bolt or whatever the last task is that we're going to do. That is an emergency, and you need to exit the space right now. It's kind of interesting. Now the video is working. I have no idea what's going on with Zoom. Ooh, nasty jobs, right? Okay, so the attendant needs to be outside of the space at all times. They need to know what the hazards are. They need to know if you're working in an environment that has laughing gas in there and the guys inside get giggly, they need to know what those effects are on the entrance. They need to identify everybody that's there. The attendant's going to be in possession of that permit, right? They're going to have that available, and they're going to document what the gas detection levels are when they do testing. They need to be able to summon rescue. If there's a problem there, they need to be able to get in touch with rescue. Now that can be a challenge sometimes if you're up the canyon where your water collection facilities are and we don't have cell coverage there. So that needs to be figured out before anybody goes into that space. They need to keep people out of a space that aren't supposed to be there. This is a dangerous place, and when we open that manhole, sometimes people want to come take a look. So their job is to keep people away. The other thing that they do is they will perform non-entry rescue. What does that mean? That means cranking the handle on that winch to pull somebody out that had a problem, whether either they were overcome or maybe they slipped and fell or they had a heart attack, whatever it was. Perform that non-entry rescue so we can get that person out and get them to start rendering aid even before the rescue team gets there. Okay, entry supervisor is the boss, and their job is to verify acceptable entry conditions. All right, so we can see that there's some hydrogen sulfide in this space. What are acceptable conditions, and determine that. No, we're not gonna deal with hydrogen sulfide until we've ventilated this space to a point where it's safe for us to go in. They need to know what the hazards are. They need to verify the rescue services are available prior to going into that space. Now, for a lot of you out there, you might be using the fire department. So this step here says that they've got to verify that those rescue services are available. Does that mean a phone call to the fire department? And my answer to that is yes. We're planning on going into, we're going to be cleaning sewer manholes today, and we may have to enter a space to get out some debris or something like that. Hopefully you don't do that. Hopefully you have some long-handled tools that you can get that stuff out. But for this example, let's just say that there's a potential that you're going to get into some spaces. Call up the fire department and say, here's what we're planning on doing today. Can you back us up? And there may be a day when the fire department says, we are on a skeleton crew because we've got everybody off fighting wildland fires, and there may be a day when you're not able to make that entry because you don't have an adequate team. They can't respond. Okay. All right. So your entry supervisor must be a competent person. They must have that level of understanding of what the hazards are and have the authority to make changes. Either bring in equipment. Hey, we need an extra ventilation fan for this to get our air levels into a safe category, or they need to be able to say, sorry, no, we're not going into this space at this point because of this, and then come up with the way to fix that. Okay, so rescue services. Like I said, never assume that your local fire department is capable or available to do this. Most of our confined space technical rescue teams are put together on a countywide basis. Now, if you're in Wasatch Front proper and you have some of the large fire agencies around you, they may have the ability at the station close to where you're at. But in most of the state, particularly rural areas, they're not going to have those resources available within their normal response time. They may be coming from multiple different jurisdictions to bring the team and the tools together to do rescue. What does that mean for us? I'll just ask you a question. How long can you hold your breath? I would not want to rely on those rescue services. I want to rely on my ability to do self-rescue and to do non-entry rescue in those cases. There may be times when you will have to provide your own rescue team because we're up the canyon and we don't have cell phone coverage to get down there, or the time is just too great for them to be able to get up there and perform an effective rescue. We may need to have our own rescue team. Okay, and I'm sure there may be some questions on this. This is an important subject, but once again, just look at your abilities there. And in some cases, you may be providing your own rescue services, and that takes a lot of training and takes a lot of equipment and time and all of those things. Okay. So these are the standards that tell us how what we have to have and how people are trained to do rescue. And I'm going to jump a couple of these here because I know I got to go. Oh, we'll let the video play. Ouch. Oh, those things are heavy. Self-rescue is the best form of rescue because that means that we've identified, hey, there's some form of an emergency or there's a reason why things could get bad here. And so I'm getting myself out right now. And just a couple of things on this. When in doubt, get out. If something isn't right, I start getting lightheaded in a confined space, get your butt out of there right now. We can figure out if you're lightheaded because you didn't eat your Cheerios this morning or whatever reason it is, but let's not hang around until we realize that I'm getting lightheaded because there's carbon monoxide in here or there's not enough oxygen in here. If the alarm goes off, get out. We have to be aware of our conditions and be aware of our physical state. What is our body telling us when we're in a space like this? We have meters and we have ventilation and all of that, but sometimes things could go differently. Sometimes you have a medical condition in there that I have to be aware of. So be smart when it comes to this stuff. Self-rescue is the way to go. Non-entry rescue is the next best. That's the attendant or another worker helps to retrieve that person, cranks them out with the winch. Now, your attendant should have a basic level of first aid and CPR training. Why? Well, if you have a heart attack down in there, they can crank you out, but when they get you up to the surface, do they have the skills to be able to rescue you and save you before the ambulance gets there, before your rescue team gets there? So some level of basic first aid and CPR training should be required for each attendant. This is not the way to do rescue. And this is not a confined space entry that I would ever do. Wow. Oh, wow. Pretty scary. Yeah, there you go. Just fold him in half. Yeah, I would not allow that if I am the competent person on that team. Okay, so retrieval systems. Everybody that goes into a permit required entry needs to be wearing a full body harness, and they need to be tied off to a retrieval line or the winch line that we have. Harnesses need to be fit to your body and all those things that we talk about in fall protection to be safe, so it doesn't hurt you if you happen to take a fall. Retrieval lines are ropes similar to static climbing ropes, right? They're not just a hank of rope that you've got in the back of the truck. This is a specific retrieval line that is connected to the back D-ring on your harness. Why is all this there? Well, if somebody is overcome, dead weight is really heavy and it's really hard to move people out of there. So we need a mechanical means at any confined space that is 5 feet deep or deeper to be able to pull that person out. And I would say I'm going to use this on any space. If it's 5 feet deep and somebody tips over down in there, it's going to be really hard to get them out. So I would have that in place. Each person needs to be tied up. It needs to be tied off. That retrieval line should be tied to a fixed object outside of the space, and preferably not the receiver hitch on the pickup, because somebody may need to go on a Mountain Dew run. So tie to a good fixed object out there so we can't pull those retrieval lines in. You say, well, I've got one person tied off to the winch line. How do I get the rest of those people out? I've just got a rope. If I try to lift them out, that's not going to work. Well, if I have those situations where I'm putting multiple responders in, we can use a capstan winch like this. You basically put a few wraps around this winch, and you can pull those lines out, and you can easily take the line off once the person is out and on the ground. So look at that. Entry rescue. This would be, for many of you, the fire department. For some of you, you have a team. We're here in North Salt Lake today, and looking out across, we have some refineries here. Those refineries have their own rescue teams. They don't rely on the fire department to do that. They have a team there. For most of us, though, we're going to be relying on the fire department. Have we had a discussion with them? Are they able to provide this kind of service? If not, then it's going to be on you to come up with a rescue team. What's their response time? What are their skills? All of those things are important questions. We need to give give our local rescue agency the opportunity to train and view our confined spaces at least once per year. Now, some of those we aren't going to be able to do that because it's a water tank or something like that, and it stays open, or it stays full most of the time. Well, the next time you're going to work on that, let's talk with the fire department and say, hey, we're going to be doing some work on this. Would you like to take a look at that and maybe train on getting somebody out of there? Give them an opportunity for that. In most cases, they'll probably say, hey, I've seen a sewer manhole before. We're not worried about it. We can handle that type of thing. But if it's a technical space, they may want to take a look at it. All right. Give them the opportunity at least once every 12 months. When do you call for rescue? And this is kind of a goofy question here. When do you call for rescue? The answer is when there may be a problem, not when you're absolutely sure that there's a problem, but when there may be a problem. Okay. Call ahead. Time is of the essence. All right, talk about a couple of things really quickly. There can be toxins in a confined space. Anything can be a toxin in sufficient dose. Even water. If I drink too much water, it can cause me to have problems with my electrolyte balance, and I can die from drinking too much water. All right, so how much is too much? Well, I got to know how it gets into my body, and I got to know what the material is. Different routes of entry, inhalation, ingestion, absorption, and injection are important. Inhalation is the primary route we should be concerned about, because if something gets into the air, I can breathe it into my lungs. It gets to my bloodstream, and it can go anywhere in my body. And so we worry about hazardous atmospheres far more than some of the other things, even though if I've got acid in there, I'm worried about skin exposure to that stuff as well. All right. So how do I know how much is too much? We have different limits out there called permissible exposure limit, the threshold limit, or threshold limit value, and ceiling limits. The PEL, the permissible exposure limit, this is OSHA's number. This is the legal amount that you can be exposed up to without getting a citation. Your employer can expose you up to 50 parts per million of anhydrous ammonia. On a time-weighted average, over your exposures can go up and down as long as in an 8-hour shift, a 40-hour week, you're not an 8-hour shift, particularly, you don't go over that permissible exposure limit. That's not necessarily the best number. If you're worried about your health, whoops, I hit the button again. If you're worried about your health, then look at the threshold limit value. Where do I find this information? Your safety data sheet should have this information in it. Okay. One last one on there is ceiling limits. I talked about that you have a time-weighted average where my exposure is going to go up and down through the shift. Some things, including chlorine gas, which some of you out there may be using, have ceiling limits. And OSHA says that you can't go over 1 part per million of chlorine gas without getting a citation there. That's they believe that that stuff's bad enough, and I go right along with them, that that we don't want to go over 1 part per million. Okay, so now we know what the limits are. If we've looked them up in our SDS sheet, what do we do with that? Okay, so we have to be able to know how close we are to any of those limits, we have to do air monitoring. Okay, this will be part of your task, is to have a meter that will test the air. This is a standard 4-gas meter. Well, what does that mean? Well, just what it sounds like, 4 different gases. It will read oxygen, how close we are to a flammable atmosphere, and then 2 toxics. And generally those are carbon monoxide and hydrogen sulfide, the nasties that are really common in industry and really in the type of work that most of you are doing, working with utilities. All right, so when do we do this testing? We're going to test this anytime before we get into a space, and we're going to continuously test that space after that. How do I make sure this meter is working right? Well, I have to check it. I take this meter, and I hook it up to something that I can expose. This is a pump that we use to test down into that vault. I hook it up to this piece of equipment that will expose the sensors to gas from a cylinder of gas that has known quantities of the gases that this meter tests for. So it has carbon monoxide, 100 parts per million carbon monoxide, hydrogen sulfide, 25 parts per million, methane at 2.5% by volume, which will give us a 50% of the lower explosive limit, and then oxygen at 17%. These will make all of your alarms go off. But I'm not worried about the alarms quite yet. What I'm worried about is my meter reading right. So I do a bump test. I hook the meter up, and then I hook it up. Then I put this hose onto this cylinder, and I read what it says on the meter. What it says on the meter should read exactly what it says on this cylinder. Oh, also make sure that your gas isn't out of date. This does have a shelf life on it. And so I read it. If it reads exactly right, I have passed my bump test. Okay, that's a bump test. It's something that you should do every time when we use that meter to ensure that it's working right. If it doesn't read right, then I'm going to do what is called a calibration. Okay, can you do your own calibration? And the answer is yes. Each one of your organizations should have somebody there that is designated as the meter guru, the person that ensures that these all work right. Now, some of you have really nice systems that will automatically bump test your meter. You just push the button and it will go through the bump test. If it doesn't calibrate right, it will give you an alarm, and it may actually calibrate it for you. But there needs to be somebody in your organization that knows how to make sure this meter's reading right. This is your lifeline. This is the thing that can determine whether you go home tonight or you go to the morgue. And so make sure this meter is working. Bump test it every time. Okay. And Mike, if we have any questions that come up that I need to answer at the time, please feel free to jump in. Just a couple of things, some basics about testing. Our confined spaces are not homogeneous. Yeah, biggest word I'll use today. They don't have the same amount of gas in every part of the confined space. I may have a gas that is heavier than air, like chlorine gas, and sinks down to the bottom. And I get a layer, a strata of really toxic gas there. So I need to have the ability to test at multiple different layers. If I'm in a vertical space, I need to at least test top, middle, and bottom. If it's a deeper space, if I'm talking many feet, then I'm going to be testing more than that. What if it's a horizontal space? Well, I may need to come up with a way that I can test inside of that space without putting myself in there to see what's going on before I get in there. Well, why don't I just dive in and test it? Well, it may overcome me. It may be a flammable atmosphere that's going to flash over and burn me to death. So I've got to do this from outside the space, test it, and test multiple layers. Okay. And some spaces are going to be harder than others. All right. So you want to have a pump. Some meters will have pumps built in. They're fine. I wouldn't personally buy one with a built-in pump just because then you've got problems. I buy an outside pump, and then it's easier to haul this around. If I'm not using the pump, it's a lot smaller and easier to pack around. But no offense, if you've got one that has a pump on it, it's just from a maintenance standpoint, I haven't had great success if the pumps are built in. I like to have an external pump, and then if I have a problem with the pump, I can throw it away and get a new one. All right, so some gases are heavier than air. I'm going to skip just due to time, but remember, stratified air can kill us. Test all of those layers to find out what's going on there. There are really cool meters now. Your meters, like I said, will generally test for 4 gases. You can put extra gases in there, or well, and I guess the question is, what if I have chlorine in my confined space? Is this 4-gas meter, going to tell me it's there? And the answer is no. It may tell you that the oxygen is lower because there's so darn much chlorine in there that it's forced out the oxygen. But I would never go by that, because remember, it's a 1 part per million, really low concentration ceiling limit. So if I know I'm dealing with gas chlorine, I'm going to go out and I'm going to buy an additional meter for that specific gas. Okay. These are, a couple $100. They're not super expensive. Your 4-gas meter, you can probably get one for $500 or $600. You can spend more, but you can get good meters for not a ton of money. This one's actually for carbon monoxide, but you can buy it for chlorine gas. Will allow me to test for those additional ones. If I have something that I don't have a way to test it, well, I need to figure out a way to test it before I put any bodies into that space. Okay, and there are other ways to do that. Please feel free, if you have any questions when it comes to gas detection, confined space stuff, hey, we just don't know quite what to do with this space, please call me. That's my job, is to help you understand your hazards and come up with good ways to deal with those. Okay, hazardous atmospheres come from a lot of things. A lot of these hazardous atmospheres are naturally occurring. They happen because our waste products are in the sewer system, and as they decompose, as they're moving through the sewer system, they release gases. And so I can have methane and hydrogen sulfide and other nasty gases inside of that space. Other times it might be things that we do. Don't ever start up a gas-fired piece of equipment in a confined space. Carbon monoxide will build up so quickly in there that you can be overcome before you even, you could think, oh, I just got to start it up. I got to do one quick cut or whatever it may be. And you'll be overcome before you know it. These small motors are really dirty, and they produce a ton of carbon monoxide, and it can take you out fast. So always measure oxygen first. Oxygen, we've got to have it. We're gonna have hopefully 20.9% oxygen. That is the natural concentration of oxygen in our air as it relates to other gases. Air around us is mostly nitrogen, and there's argon and carbon dioxide and a few other gases that are probably floating around in there. But 20.9 is where we want to be. 21% if you want to round up. But you should have these numbers memorized. How much is not enough oxygen? It's less than 19.5% oxygen. And we also have another number, that bottom one there, which is IDLH. This is where you're going to die, or you're going to be overcome, or you're not going to be able to get out of the space, and that's less than 16%. Now we have to realize, oh, and let me cover this one before I move on to that. We also have oxygen enriched atmospheres. What does that mean? Well, if I'm over 23.5% oxygen, that can cause things to burn that don't normally burn, or burn a lot hotter. Doesn't mean I can't breathe high concentrations of oxygen. If you get COVID, they're going to put you on oxygen if you have trouble with your lungs, or if you have whatever it may be, medical thing. If I'm not getting enough oxygen, they may put me on 100% oxygen if I'm having enough trouble there. But oxygen out in the environment, if I'm over 23.5%, things might flame up. My clothing may flame up. So we have to be really careful of that. So just a thought, we live in the mountains, most of us, in a valley. We're definitely at a higher elevation than sea level. What happens to the concentration of oxygen as we go higher in the atmosphere? Well, and I asked you the question, what about on top of Mount Everest? What percentage oxygen are we going to see on top of Mount Everest? And it's kind of a trick question, because the answer is it will be 20.9%. You say, what? Really? The answer is yes, it'll be 20.9%, because this meter measures the relative concentration of oxygen to nitrogen and the other gases that are in the air. Up on top of Mount Everest, it's still 20.9% oxygen, but there's a lot less of it because the pressure is a lot less on the atmosphere. And so there's just not as much total gas in a given volume, a given breath of air that I take in. So we mostly are at least St. George, you guys are probably 3,000. I think you're about 3,000 feet elevation there. Most of the rest of the state is going to be above 4,000 feet, and a lot of you out there will be above 5,000 feet. Does that have an impact on the oxygen? The answer is yes. There's less total oxygen in a given cubic foot of air. So I got to make darn sure that I've got 20.9% oxygen in whatever confined space I'm getting into, because I know I'm already at a deficit when it comes to the amount of oxygen. All right, I gotta move. I'm gonna jump a couple of these. Always measure oxygen first. It's essential. The other meters don't work. Is not gonna work as well with without sufficient oxygen. So what does it take to make a fire? The second gas that we're going to measure is how flammable the atmosphere, the percent of the lower explosive limit. So you'll read on there, it'll say percent LEL. That means how close we are to having an explosive mixture of gases in the air. Your meter's going to go off at 10% of the LEL, not 50% or 90%, because this could explode and kill you, and things change really quickly. This is why we test. This is why we ventilate our space. Methane is not that high involves. Test and ventilate your spaces, because burning to death is a really bad way to go. Carbon monoxide, we've already talked about this one. The PEL is 50 parts per million, but your meter is going to go off at 25 parts per million and tell you that's too much carbon monoxide for you. You need to get out of that space. This stuff will bond with the hemoglobin in our blood and make it so I can't uptake oxygen to my tissues. So carbon monoxide, dangerous stuff. Hydrogen sulfide, even nastier stuff. This stuff at low concentration smells like rotten egg gas. Okay, like, dude, you know, open a window or light a match, whatever. At higher concentration, this stuff turns off your nose. It's called olfactory fatigue. It makes it so I can't smell the stuff. And at 10 parts per million, your meter's going to alarm. 20 parts per million is the PEL for hydrogen sulfide. And at high concentrations, this stuff is going to make your heart and lungs stop working. And it is bad stuff. Okay. All right. Excuse me, I think I said that right. The PE said that wrong. The ceiling concentration is 20 parts per million, and the PEL is 10 parts per million. All right. And then once again, have look at your gases that you're dealing with, and come up with the appropriate gas detection for those. If I've got chlorine gas, I got to have a way to measure it. Okay. So there's our limits again. These are numbers that you should know, because if I'm flirting with 25 parts per million carbon monoxide, I need to know that before I ever go in. That's telling me that there's something going on. If there's hydrogen sulfide in that space, I got to deal with that. I've got to ventilate that space, because that stuff is just too darn dangerous for me to get into a confined, concentrated atmosphere. Okay, along with our gas detection, we want to ventilate the space. And hopefully we're not going to do it like this. Luckily, these guys are at least trying, right? This is not the best way to do ventilation, and we have much better ways, but these guys are trying to make their space safer. All right, so ventilation is important. It should be continuous. We should put that hose down into there and continuously ventilate the space. Now, I'm gonna take one little sideline here. If you have a flammable material inside of a confined space, don't stick a hose in there and ventilate that space, because basically what you're doing is creating a bomb. There's going to be special procedures for that. I don't know of anybody out there that will be dealing with that, but if you are, let me know. The guys at the refinery across the freeway from us, they inert their spaces. They pump nitrogen gas in there to make sure there's no oxygen in with that gasoline in the tank. But their people have to go in on supplied air respirators to be able to safely go in and out of there. Okay, so we ventilate. There are two different types of ventilation that we do. There is dilution ventilation, and this is the most common one. We take a fan and we dump a whole bunch of clean air in there to dilute out the bad stuff that's in the space. The other type of ventilation is called local exhaust. I might do these at the same time. I put a hose down into a sewer manhole where the main line is coming in, because there's some bad gas eking out of that thing. And I take that hose and I put it right where the gases are coming out of the main line, and I draw the bad stuff out. You should store your gases safely. So I'm going to be pulling the bad stuff out at the same time as I'm dumping in clean stuff. You got to be smart about where you put these fans, so I'm not dumping bad stuff out into the inlet where I'm taking in the air. So pick out which way the wind's blowing. Don't put your fan by the exhaust pipe of the truck, so we're dumping in exhaust vapors and carbon monoxide there. Be smart about ventilation. Test and ventilate. Those are critical parts of doing this job. Other hazards that are in there: water. We may need to pump water out of a space prior to making an entry, or sewage, or whatever it may be. So that might be pumps or back trucks that we'll be using for that. Electrical, mechanical things. Lockout, tag out is an essential part of a confined space program, because I'm going to isolate those energy sources prior to having anybody get into there. All right. So just a couple of things. Several years ago, they changed a few things in the standard to continue. One of those things was to go to continuous air monitoring. So I want to have not just a test when I start and every 15 minutes. I want that meter running the whole time that I'm in there, because if something changes, it can change really quickly. Continuous monitoring of engulfment hazards. So if water's rising or things like that, I'm going to be monitoring anything that could cause an engulfment to happen. Down in southern Utah, one of the things that could cause engulfment is and it's not just southern Utah, it's anywhere, but southern Utah is more exposed to flash flooding than the northern part of the state. But you're out there working in a confined space, and there's a flash flood warning for that day, and you're at a low-lying area. Well, I need to be monitoring that on a continual basis. And my tenants should be doing that to ensure that we don't get somebody trapped and engulfed in there. Okay. All right. Just a quick summary on this. Know your spaces. Always test and ventilate those spaces. Bump test, calibrate your meters. Bump test every time. Make sure that meter works. That's your lifeline. And the only way I can tell if it's working right is if I bump test it. If you ever pull your meter out and you're looking at them outside, I turn it on and it's showing a negative number, that means that the meter probably means that the meter was zeroed in dirty air. And that's going to mess up the slope that you're calibrated on. So it will need to be zeroed again. So take it and do your bump test and do your zero. Talk to the meter guru that you have and say, hey, this is reading less than one, a negative number, and have them, or less than zero, have them do that zero on the meter. Know how to use your meters. Know what those numbers mean. Know what the alarms are going to go off. Know your entry roles. That attendant needs to stay outside of that space, and they need to be in contact with everybody that's in there at all times. And then think about your your services, evaluate them and ensure that they're adequate to keep our people safe, get them out if we have a bad situation. Think. This is your life on the line when it comes to this. Okay. One of the other big dangerous jobs that you do out there is trenching. And these jobs sometimes come up unexpectedly in the middle of the night in a rainstorm, and all of a sudden we've got a line break on a water line. We've got to go out there and dig it up and be able to make it safe. This is one of the more frustrating topics in the safety world to me, because it's every year we will have some trenching fatalities that happen, and it's just unnecessary. These are things that people would use the equipment that's available and do it every time. We wouldn't have these problems, and it's just a sad thing when I see another contractor tip over. I never want to see one of you guys be in this situation, and unfortunately, we've had a trench fatality and some really significant injuries from people being buried in trench collapses. Let's make the commitment today to do it right every time. And if it means it's going to take a little bit longer to get that trench box, that's okay. We're going to do it right. Okay. Wow, how'd we do? that was a terrible, terrible situation. We had people down in a, I think there'd probably already been a collapse and somebody was buried. There was somebody down underneath the bucket working there. What about the hoe operator, the excavator operator? As he's pulling that out, he probably took away the one thing that could have saved the people that were down buried there, was maybe that air pocket. Anyway, terrible thing, and we've seen it happen. You know, it's not something that just happens in other countries. This is something that happens in our backyard, and it's on an annual basis. We'll see these trench collapses, and it's just a tragedy that doesn't need to happen. So, number one, always protect yourself first. Think before we go in. When in doubt, get out. If something doesn't seem right, get out of that place. All right. So we're going to talk about these hazards. 1 of every 5 workplace fatalities is a construction worker, and excavation fatalities are a lot higher than regular construction. This is dangerous work. With the exception of falls, this is right up there as some of the highest fatality rates of any job that's out there. Okay. And it can happen to you. It can happen today. So let's set those goals that we're going to do it right each and every time. Okay. Once again, it's an OSHA standard. It's a construction standard because we're digging holes in the ground. And so it's going to be based around construction. Okay. And it says that it applies to excavations in the Earth's surface, and trenches are part of that. So a trench is less than 15 feet in width, right? If we get much further than that, the chances of having a collapse that's going to smash you against the other wall and bury you go down. Not that it can't occur in any excavation, but we're talking specifically trenches today. It's longer than deeper than it is wide. We have a competent person. We introduced that in the confined space training. A competent person determines what's required for the safety needs there, what needs to be in place. If we're digging greater than 20 feet deep, we have to have a registered professional engineer design and sign off on the excavation. At 20 feet deep, things really start getting goofy. And unfortunately, a good chunk of our sewer mains end up in that 20-foot plus, not a good chunk, but some end up in that 20 plus foot depth. Any trench has the potential to kill. And unfortunately, we've seen some people seriously injured in 3-foot deep trenches. We've seen, a guy bent over installing some conduit down in the bottom of a 3-foot deep trench when the wall collapsed and crushed him against the other side of the trench. Buddies kind of chuckled when they saw it happen until they realized that this guy was really seriously injured and had life-altering injuries in a 3-foot deep trench. So any trench can be a killer. So respect those things. Respect every confined space as well. I don't know if you'll be able to see that video, so we'll jump on. Once again, competent person needs to be designated there. Who is a competent person? Somebody who has knowledge to identify the hazards and the authority to do something about it. So on an excavation site, the competent person's responsibilities are to be there present when employees are in the trench. We've got to have a competent person present. Determine how we're going to give protection to the employees. In shallow trenches, sometimes we can slope and bench that, and the competent person can help to make the decision, is sloping appropriate for this situation. Performing soil tests so we understand what the risks of the soil is that we're working with, and document those soil tests as well. Performing inspections prior to the start of the workday and as needed. So every day that competent person should be signing off. And one of the things that I'll send you out for everybody that signed up is a daily excavation inspection chart or form. And whoops, excuse me. And what that has is just a list of things that competence person should be checking each and every day that we're working on an excavation. As the day goes on, we may come into different hazards. We may find different soil types, and the competent person needs to help evaluate those hazards as we go along. Competent person also has a responsibility to evacuate people from the trench if there's evidence that a cave-in is imminent, even if we're in a trench box, right? All right. One important step prior to digging is to locate utilities. And in many cases, you are going to be locating your utilities, the water and sewer lines that you supervise. But what else is down there? And we also have to give some leeway to those utilities. How far back from a marked utility do I have to stop digging? How far back do I have to hand dig? And it's really 2 feet away. Now that may not always be enough. Given your experience out there working in your areas, sometimes those located utilities are not exactly where they're supposed to be. And so we give them sufficient leeway to protect our people. All right. If my trench is greater than 4 feet deep, I need to have some means of entry and egress, a ladder or a ramp or some way to get in and out. So anything deeper than 4 feet, I need to have that within 25 feet of travel. Okay, so you say, well, 25 feet, well, my trench box is not that big. Well, your egress means your ladder needs to be there inside the trench box with you. Now, let's say I'm working in a trench that is 4 feet deep, and the competent person or a little over 4 feet deep, has determined that there's no imminent collapse that can happen there. And so I'm able to work there without a trench box. Then it needs to be within 25 feet of where I'm at. Okay. All right. So identifying these utilities is key to keeping us alive. And just along with that, your traffic control. Your traffic control, people are not paying attention. Make sure that we are controlling the access there. And if it means that we put some equipment in the way to block people's access to where we're at, so be it. All right. So in the OSHA standard, it talks about surface encumbrances. And you say, what the heck's a surface encumbrance? It's something on the surface that could impact us. It could be curb and gutter that we're digging right next to that could break free and come in on top of us. It could be a tree, it could be an irrigation canal, it could be a building, anything like that might produce a hazard to employees that are working in there. We got to deal with that. We got to shore it up, remove it, whatever it may be, to ensure that it doesn't present that hazard to our workers that are.
Só mais uma pegadinha. Vem! Vem o delúvio! Uia!
Okay, that is a nice boulder. I like that boulder. All right. So before you dig, make sure that we've got our traffic control in place. Flaggers, blocking, whether it's vehicles or whatever it is, to keep people out of there. People are not paying attention. Keep yourself visible, wearing retroreflective vests, falling loads. If you're in a trench, you're on a construction site. And as such, you're required to have head protection. So head protection, including hard hats, foot protection, including steel-toed shoes, or safety shoes that meet the standard. These are requirements of working in an excavation. Okay, don't get under raised loads. If we're lifting something into place, do not get underneath it. And even around it, we've got to be careful. Even running a tag line can get us into trouble there. Okay. All right. So before we dig, we need to ensure that we've got a competent person that has inspected the trench, that we are doing those daily inspections of our excavations. We may need to test the atmosphere. So going back to our confined space stuff, certain types of strata will produce gases that can be dangerous to us. Those gases could be methane. They could be things that produce carbon dioxide. Certain types of limestone, when it's disturbed, will produce carbon dioxide that is maybe not that hazardous to us as just a gas, but it can force out the oxygen that is there and cause us to asphyxiate, to not have enough air to breathe. So we may have to test the atmosphere in this excavation. Keep our excavated material at least 2 feet away from the edge, and I would say greater than that. And the purpose of that is we don't want to put excess strain onto those trench walls, and we also want to be able to inspect the area around the trench to look for cracking or things that might indicate that this trench wall is unstable. Deal with water or other liquids or things like that that can engulf us. Water in a trench is the sign of a very dangerous trench. So we may need to be pumping that water out. As we pump water, that can sometimes cause hazards as well. As that water funnels into there, it can undermine things. I'm not saying don't pump it out, but we have to be aware that a wet trench is a dangerous trench. All right. So just quickly, what is soil? Soil is very small rocks. We have air pockets in there, air bubbles in there. There's water, there's organic material, there's all kinds of different things. And there are a lot of different soil types. And in any excavation, you may come upon a dozen different soil types that we have to deal with. There can be voids in there. They can all of these things. Soil is heavy. Solid rock weighs about 167 pounds per cubic foot, depending on the kind of rock. But soil is over 100 pounds per cubic foot. How many yards or how many cubic feet are in a yard of soil? If you're in a room, shout it out. How many yards are in a cubic foot of soil? 27. And so I times that by 100 pounds each. I'm working on 1.5 tons of weight in a simple cubic yard of soil. If that's on top of you, you ain't moving and you're in trouble. You're going to be hurt badly by that kind of weight. And sometimes even people who are rescued from a trench collapse will still pass away because of the weight that's been on them and the damage it's done to their bodies. Sometimes we have when that weight is taken away, our body, it's called hypovolemic shock, and our blood will basically surge out of our upper body down into those areas that had all the pressure on it. And it's like a pump that loses prime, and we can tip over and die from that, or just the catastrophic injuries that can happen from it. So this is not something to mess with. Gravity always wins. Wherever you're at, you look out the window, there's probably some mountains somewhere around there. Eventually those mountains will be flat. You've given enough time. Gravity's going to win. And so when I dig that trench, it's going to try to flatten those walls. Gravity's going to try to tip that down. How quickly that happens depends on the soil type and depends on what type of controls we put in place. But remember, gravity's always going to win. That trench will collapse. These forces are crazy extreme. When I start stacking up 100-pound, 1-foot square blocks of soil there, and they let go and come in on top of me, our chances of surviving are not great. Okay, this is your life that we're playing with, and so we want to ensure that that we're doing it right every time. Now, these are just a couple of cutaways from a trench. Where is the weakest part of that trench wall? Well, I can't necessarily answer that question 100% because I might have a weak layer of soil somewhere. But let's say the soil is all uniform from top to bottom of that trench. The bottom part of that trench wall will be the weakest because it has the most weight on it. And generally speaking, the deeper we dig, the more wet the soil gets. So you might see a little kick out at the bottom of that, trench. That is an absolute warning sign that this trench wall is going to collapse. I've heard people tell stories about being caught in a trench collapse that was just the bottom of the trench, but it came in and it buried them to their knees or to their ankles, but they weren't able to move. Is this a bad spot? Yeah, because now we've undermined that trench wall, and the secondary collapse might be the thing that gets us. It could be our buddy that's running over to throw us a shovel so we can dig ourselves out of there that causes that secondary collapse. Or if they happen to dive in, which you shouldn't, to dive in there to help get you out, it may be a multiple person collapse where we bury a couple of you or multiple people that are in there. So you're saying you're out there saying, you're telling me not to help my buddy? That's not what I'm saying. I'm saying don't dive in there. Same as a confined space. Don't dive in there. If you can safely get that guy a shovel so they can try to dig themselves out, do that. But when a trench collapse happens, this is an emergency and this is a 911 call. And if we don't get this person taken care of quickly, that secondary collapse could take them out. All right. This is just a picture. I was out on a excavation site one day, and I'm like, oh, there's a little kick out at the bottom of that trench. I better take a picture of that. All right, here's CDC or NIOSH has a great little interactive thing. They talk about the different types of collapses that can happen. But before I dive into that, what about this guy? Is he in a bad spot? The answer is yeah. This guy is in a bad spot. He's not going to be able to wriggle his way out of there. They got a rope tied around him. Are they going to pull him out with that rope? The answer is no. They'd probably pull him in half with that. The rope is there to help him find the body if this collapse happens. You look here, we've got an overhanging wall. This guy's in a bad spot. Let's not get there. Let's do it right each time. Okay, so we talk about the different types of collapses that can happen. If I put my spoil pile too close to the edge of the trench, it can slide in on top of somebody. They call that the spoil pile slide. The shear wall collapse, and that's basically where we get cracking and the entire wall comes in. The belly slough, this is where I might have layers of different types of soil. And so I've got some more solid soil up top. I got clay up top, and then I've got some gravel or sand in the middle, and then maybe some solid stuff. This is called the belly slough, where that center part can kick out, bury a guy, trap that person, and then we've got this upper layer that's suspended. That's going to take rescuers a long time to shore up. Let's do it right to start with. Let's make sure we've got the protection in place. The lip slide is kind of similar to the spoil pile slide, but it's basically the top of that trench will slide in. Now, a lot of excavator operators that are out there, if we're in open country, that hoe operator might wipe off that lip as they're digging. Now, if we're in asphalt, cutting asphalt, things like that, may not be possible. But in open country digging, if that operator can smooth those edges a little bit, we can minimize the chance that we have that lip slide, and at the same time putting the spoil pile back far enough. All right, so different types of soil. This class is not intended on making you an expert on identifying soil types. However, we can talk about some real basics that will help you understand what would make a trench more dangerous than another. Now, your competent person should have some more specific experience and training on doing these types of soil tests. But let's talk about the different types of soil. There's some basic types. We go from solid rock. That's going to be our most stable type of soil. Next to that, what would be the most stable type? Clay is probably the most stable unless. And what's the unless? unless you add water to it. If I get a lot of water in clay, it can basically become jello. And so understanding that it's not just the soil type, but also the environmental conditions, how much water is available in the area, that will determine how stable that will be. And then the bigger the particles get, the less stable it will be. So sand would be a little more stable than clay, and gravel would be less stable than that sand. Okay, so we take our soils and we test it and we classify it into one of 4 different types. One is solid rock. We won't spend much time talking about that. I think most people can identify solid rock. But then we have type A, B, and C. Type A is the most stable soil type, and C is the least stable. We need to do at least 1 visual and 1 manual test to classify the soil. So a visual test, I'm going to look at the soil and say, what does it look like? How big are the particles? Well, I can see there's cobble rock in there like that. Well, that's going to be a gravel, right? That makes it fairly easy if I can see I've got these big particles in there. Is there water present? Like I said, a wet trench is a dangerous trench. The presence of water is really going to help us in our classification. I can't call it a type A soil if I've got water standing in there. Cracking and spalling. So you can see in this picture, there are particles flaking off of this wall. That's something we call spalling, where I get little particles will break free, and it's just kind of a continual process that the soil is crumbling. That's a risk factor. Okay, cracks in the soil will help me as well to identify the risks of the soil. Okay. All right. So particle size. Gravel is divided up into, well, we call it gravel if the particle sizes are bigger than a pencil lead. Then it's going to be gravel. And I have 2 different types of gravel, angular and round. What would be the difference between a river rock, nice rounded edges, and angular crushed gravel? Is one going to be more stable than the other? And the answer is yes. That crushed gravel, that angular gravel, has a tendency to lock together with those edges, whereas round stuff has a tendency to slide over the other particles that are in there. So round gravel would be a type C soil. An angular gravel, we could potentially, in the absence of other factors, call it a type B soil. Sand would be more a type C. You think about that. How stable is that sand going to be? Now, obviously, there's a continuum on some sand is more stable than other. Down in Washington County, you have that blow sand down there that you can stand on it and sink into that because it's not that stable. Then we have silt, which you can imagine really small particles, and then clay has the smallest particles. And as it becomes really compacted, if it's native virgin clay that hasn't been disturbed, that stuff can be really stable if it isn't too wet. All right, so here's some warning signs for soil. Cracking, spalling that we talked about, sloughing, where we'll have materials that will slough off of the side, heaving, where it will push up through the bottom, and boiling along with that. If you've ever seen a trench where I've got water that's coming in, you may see little particles. You can see the water bubbling up, and there's little particles bouncing around in there. That's something we call boiling, and is a real warning sign that this is not a safe trench to be in. We've got to have all of our game pieces in place for that trench. Okay, so those were visual tests, and then we're going to talk manual tests. I've got to put my hands on the soil, pick up a clod out of the spoil pile that the excavator just dug out, and let's do a test on it. There are a couple of different tests, well, several tests, but a couple of things that we're looking for. One is cohesiveness. How sticky is the soil? And the other is compressive strength. If I put a load on this, is it going to stand up or is it going to fall apart? So let's talk cohesiveness to start with. I've got my Play-Doh here, and I'm going to do some tests to see how cohesive. What do you think? You think Play-Doh is going to be cohesive? And the answer is yes. This is sticky stuff, right? So, uh-oh, my Play-Doh dried out. I got all of my I got all of my props ready to go early this morning, and my Play-Doh's dried out just a little bit. So, cohesiveness, it needs to be a type A soil needs to be cohesive to be a type A. Okay, depending on the amount of how dry the material is, it may be a B or C. So this Play-Doh that I've allowed to dry out, I'll show you right here. Here's a thread test. I take this material and I made a thread out of it. Okay, this isn't quite 1/8 of an inch, and I pick it up off of the table. And if I can pick up a piece at least 2 inches long, that's going to tell me it's a cohesive soil. Now this is obviously very cohesive. As it dries out, though, it may become less cohesive. It might break. Okay, that's the thread test. So take it, roll it into an 1/8 of an inch cylinder and pick it up. If I can pick up 2 inches, that's telling me it's cohesive. Another cohesiveness test is the ribbon test. So I take a chunk of the soil, I roll it out, and then I start squishing it and letting it roll off of the end of my fingers there. If I can get a couple of inches that off of the edge, that's going to tell me it's a cohesive soil. And I can even classify it, whether it's loam or clay based on the amount of that stuff that will hang off the end of my hand. Okay. Then we're going to do the strength test on this soil. So I take that clod of material and I can do what we call the thumb test. Now, I don't like this test too much because I think everybody's thumbs are different. But basically it says if I put quite a bit of effort on this, and it's easily penetrated, it's called. So with this Play-Doh, it's going to be easily penetrated. That's going to be less than a half ton per square foot pressure that it took to do that. We're going to call that a type C soil. If my thumbnail, I put a significant pressure on there and I can just penetrate with my thumbnail, that is going to be a type B soil between 1.5 tons and a half ton of pressure. And then a type A soil, I can't really even scratch the stuff, right? I can indent it, but I can't penetrate that without pushing crazy hard. Okay, that's going to be a type A soil. All right. Now, like I said, I don't like the thumb test very much because I think it's a little more subjective. So you can buy a tool. And what's in the picture here is one of these. It's called a pocket penetrometer. And basically, I take my clod and I push on it. And you can see on here, there's a little red line. And I push on this clod until it penetrates to that red line, which is about 1/4 inch. And what happens, you can see the little red line on here moved. And I can read on here, it tells me that I'm at 1.5 tons per square foot. And I can get a physical reading. So should you own a pocket penetrometer? If you're doing a lot of excavation, you should own one of these things. They have them. This is a nice stainless steel version, and I think it was about $80. But you can buy a plastic version of the same thing for like 20 some odd dollars. As a competent person, you should have a pocket penetrometer. There are other tests that you can do, but these are the real simplest ones. And they'll help you to classify this soil. All right. So, like we said, clays that don't have too much water in them will probably be a type A soil, 1.5 tons per square foot. It's cohesive. It is not a type A soil if it's got cracks in it, it's fissured. If it's subject to vibration, oh, I forgot, I had a new video that I was going to put on here, and I and I forgot to put it in. I had a great vibration video showing this excavator on soil that was just going down and down and down, just from the excavator moving. If it's subject to vibration, so if you shake it and it can and the soil becomes less stable. You think of quicksand, different types of soil there. I jiggle this stuff around and it becomes less stable. If water's present, it can't be type A. Okay, there's a little water at the bottom of the trench. You're not calling that type A soil. Okay, vibration comes from a lot of things. It can be our equipment, the excavators that we're using, backhoes, compactors, you name it. But certain types of soil are subject to vibration, and the work that we're doing can cause it to collapse. There may be a railroad nearby, or traffic, or other things that can bring that vibration as well. Okay, so type B soil between 0.5 ton and 1.5 tons per square foot. And these are the types: silt loam, sandy loam, and some sandy clay loam. Or if it's previously disturbed, and you say, well, what do you mean previously disturbed? That's exactly what I mean. Sometime it has been dug. Well, how long does it take to get back to undisturbed state? Well, probably longer than your life. Most of the places that we are digging will be out in a roadway that has been previously disturbed. And so if it's previously disturbed, I can't call it type B. Okay. All right. Whoops. Boy, I'm having trouble with the buttons today. Type C soil is what I would go with in almost all cases, just because that's going to be the safest for me. It's less than a 0.5 ton per square foot pressure with my pocket penetrometer. These are granular soils like gravel, sand, and loamy sand. You think about doing my Play-Doh test, right? If I picked up sand and tried to roll out a thread, it ain't going to work. If I tried to do a ribbon test and crush this over the side of my hand, it's not going to work. I can't make this stuff any better than a type C. Okay, and here's the answer on this. Why I don't worry about training everybody up to be soil scientists and to be able to identify all of these soil types is this last line. I tell you to call it type C on everything, and then you're covered. Because we're only going to use this for one thing, the type of soil, except for our general knowledge of, hey, this is more dangerous soil. Okay, and that one thing, well, if we are sloping or benching our excavation, then soil type becomes a big factor. But once again, call it type C, and then you're covered. Okay, we need to provide protection inside this trench to protect anybody that is inside of there. So there are different ways that we can use it. There's sloping and benching. Shielding. This is our trench box, right? We're not trying to stop the collapse from taking place, but we're shielding the workers from that collapse and keeping them from getting buried, knocked to the side, and all of those things. So that's shielding. Shoring, we're actually trying to keep those walls up. Maybe I've got a building next door and we're doing this excavation and we don't want the foundation of that building to collapse, or we don't want the building coming in on top of us. So we'll do something called shielding. We put pressure against those walls to prevent them from collapsing. That's called shoring. Inspections. We're going to be doing regular inspections. We already talked about that. And then rescue. Who's going to do rescue, and what are their qualifications, and are they available, and all of those things that we've talked about. Okay, what do you think? Think you can make it? Yeah, I didn't think so either. We got to have a way to get across our excavations as well. a way to get out. So we have to have that safe access and egress. Like I said, if it's deeper than 4 feet or at 4 feet, I've got to have that ladder or ramp. Where does that need to be? If I'm working inside of a trench box, that ladder needs to be in the trench box so I can escape from that, get in and out without putting myself in danger, leaving the trench box and going out into the trench. All right, I'm skipping a couple of these videos just for the sake of time here. So here's the OSHA standard. This is everything on trenching. There's lots of stuff that it talks about in here, but this is the important part. It says each employee in an excavation shall be protected from cave-ins by an adequate protective system designed in accordance with paragraph B or C of this section, except, so it says you got to have protection in place, except, and everybody's like, okay, I'll look at that. And so there are 2 different exceptions here. If excavations are made in entirely stable rock. So if you're down in Moab and we've got something that can excavate slick rock, right? That sandstone, and I have a totally solid rock trench, I don't have to put protection in that, except for maybe stuff that might break off and fall onto me. And here's the other exception that a lot of people go with, and it can get you into trouble. Except when excavations are less than 5 feet in depth. Most people stop reading right there. Hey, it's less than 5 feet, I'm good. That's not the case. We got to read the and examination of the ground by a competent person provides no indication of a potential cave-in. So what does that mean? Does that mean I could be using a trench box in a 3-foot deep trench? The answer is yes. If the competent person determines that there is a potential for collapse there, then they're going to specify protection. Okay, but anything deeper than 5 feet or at 5 feet or deeper, you have to have protection in place. What is that protection going to be? Well, it can be a number of things. In those shallower trenches, we could be using sloping or benching. And we do that based on the soil type. That's like I said, the one thing besides just general knowledge of is this safe or not, this is the one thing that we use those soil types to really guide us on. In type A soil, I don't have to slope it nearly as much as I do with type C. And so here's our slope angles. In type A, it's 3/4 of a foot to every foot of depth that we've got. I've got to do that 3/4 foot out. 1 foot to 1 foot for type B, and 1.5 to 1 for type C. So when I told you to call everything type C and then you're covered, that's what I'm talking about. So I'm going to go for every foot, I'm going to go a 1.5 feet out. What does that mean as I get deeper? Can I go 20 feet deep? The answer is yeah. But what does that mean? If I start going 1.5 feet out for that, well, this is going to be a massive excavation. There's a company called Trench Safety. I think their website's trenchsafety.com, and they have a slope calculator on there that will tell you how far out you need to go based on the depth and the width of your trench and the soil type and all of those things. And what does this company sell? Well, they sell trench boxes, because they know if you go in and you actually do the calculation correctly, you're going to say, you know what, we're just going to buy a trench box. We're not going to slope this thing out because it's going to go way too wide. Okay. So type A, B, and C, when I'm talking 1.5 to 1, that's way out there. What if I have layered soils? Can I have a compound angle? The answer is yes, but only if the more stable soil is on the top, right? If I've got type C at the bottom, I'm going to do 1.5 to 1 all the way up, even if I've got type A soil up on top. Okay. Here's kind of a well, there's the website trenchsafety.com/slope calculator, and you can see really what it tells us. It tells us that we need to use protection versus sloping. Now, in really shallow trenches, sloping can work, but in most cases, let's get a trench box and put that thing in there. So a trench box is a shield. It protects us from being impacted or buried from that collapse. It's put together with various panels, with spreaders that go in between. This is an engineered system. Don't replace parts with just stuff that you find out in the shop. If I lose a piece or a piece becomes damaged, I need to go back to the manufacturer and buy the replacement part for that. They need to be used as they were intended. There may be a pipe that's going through right where that bottom spreader is. I can't take it out for that utility. I've got to get an appropriate device there, trench box for those things, or I may have to shore that excavation up. The rigging that we lift this with must be certified, and so your chains that you use to hoist that, or cables, those will all have a tag on them listed as certified and what their load capacity is to be able to lift that around. The excavator operator, well, let me go back to this picture. You look out on the bottom of this trench box, and it's pointed. It has what we call a knife edge on it. What's the purpose of that knife edge? Well, that is really to penetrate the bottom of the trench and anchor the trench box in place. And the excavator operator, backhoe operator, should actually force this trench box down as they put it in place. So those sharp edges go in, and then if a collapse happens, it's going to be securely in the bottom of the trench, so it doesn't shift side to side. It also keeps stuff from coming up from the bottom. Okay. All right. Like I said, ensure that we have all of the parts in place, the pins and keepers, and all of those things. Now, in our dreams, we have a trench box like that. Those are pretty slick, but most of us won't have that. The trench box will either be already put together, or we'll put it together out on the job site. And then the excavator operator will place it into the trench, make sure the spoil pile's off to the side, lift and lower the shield into the trench, make sure we got proper egress. How do we move it? Well, we get all of our bodies out of there, people out of there, and then the excavator operator is going to, in stable soil, just pull the shield forward. If it's in unstable soil, they're going to lift it up and then pull it forward as they go along. It says on this slide to backfill the job as we progress. What's the purpose of backfilling as we go along? It's really to ensure the stability of that trench. And so if I can go and fill that in, then we don't get that chain reaction collapse that can happen. So backfill as we go along. Okay. Some limitations of shields. If they're missing parts, they're not going to work right. If we haven't selected the appropriate shield for the job, if it's too or not tall enough, it can come over top of us and bury us anyway. It needs to be installed correctly at the right height. And we want to have the proper length, width, and height. So if I've got a bucket that is 6 feet wide, and I bring in a trench box that is barely 2 feet wide, well, that's going to be risky to me on this job, because this collapse could actually tip the trench box. So buy the trench box to fit the trench that we're cutting, and if we need a different trench box, they're available. You can rent these things. If you're doing regular excavation, you ought to have one on site all the time. If it's periodic thing, let's make a plan, and we can rent these trench boxes and have them on site. Oh, just one thing quickly. Can I stack trench boxes like we see in this picture? The answer is yes, if it's designed for it. And so you'll want to look at the tables, the information that comes along with the trench box, and if it allows it, then you can do that. They need to be pinned together so they don't slip side to side, and I can do that. Now, can I have a trench box in conjunction with a sloping or shielding? And the answer is yes, but at the bottom of that, or at the trench box, the top of the trench box should be at least 18 inches above where my slope comes in, so stuff can't roll down that slope and into the trench box. Okay. All right. Just as an example, we want to talk about graves, because there are probably a significant number of you out there that dig graves. Is it a trench by definition? And so we say, well, is it longer and deeper than it is wide? And the answer is yes. Is it greater than 5 feet in depth? The answer is yeah. In most cases, it's going to be that. Is it in disturbed soil? And in many cases, it is. We've already planted Grandpa a few years ago, and now it's Grandma's turn. And so we're digging into previously disturbed soil. What's the soil type? Who knows? What's there? Is there water? Yeah, and most of our cemeteries, they receive a significant amount of water. We want to keep them green and looking nice. So it's a trench. Do you need to have a trench box in this? If you're going to get into that grave, yes, under OSHA standards, you need that. Under safety standards, you're going to need to have protection in that trench, shoring or shielding. And so why do I bring this up? Well, I think there can be a temptation to just jump into that grave to square up the corners so the vault fits down in there nice and level and all of that stuff. Here's the deal: get some long-handled tools to do that, or buy an implement that will work. You can see in this picture, this is one of our members. I took this out at their shop. They have, it's called a grave digger bucket, and it's the right width for a vault, so you can make one pass, and it's wide enough for a vault. Those edges on the side are just like razors. They'll cut a nice really sharp edge on that. But the nice thing about this bucket is I can dig completely vertically, and so I can square up the corners with this bucket. So we're going to spend some money to buy this, but I'm not going to have to be dragging a trench box out into the cemetery and busting up the headstones and all of that, or heaven forbid we take a risk on putting people into that. Anyway, let's be smart about how we do this. If you don't have to get into a confined space, don't. If you don't have to get into a grave, don't. All right, just briefly on shoring. Most of you out here are not going to be doing shoring. You're going to hire somebody to come in and do that work for you. This is where we don't want those walls to collapse at all. And so we're bringing in generally hydraulic or other mechanical shoring systems to put pressure on the walls to keep them from collapsing. Here's a diagram kind of showing, this is a whaler where I can spread out that hydraulic pressure over a bigger area. I put walls in. Here's a fixed system. These need to be installed, not a fixed system. This is a pre-built system that you can take to an excavation, and we just drop these in from outside. I don't enter the trench to install shoring. I do it from outside. So I drop the panels in, the walls, and then the hydraulic shoring in there, and I pump up pressure to hold those walls up. A few different examples there. But like I said, most of us out there aren't going to do that. We're going to say this is beyond our ability to do this type of work, because we don't do it all the time. So we're going to bring in a contractor to do it. Okay. Like I said, I'll shoot out these sample documents. We have a daily excavation safety checklist and a soil analysis checklist. I'll shoot those out to everybody that signed up today. And if you've got multiple people that are there watching it, share those around. The inspections need to be performed by a competent person before the start of work and throughout the day, or if a hazard increasing occurrence happens. What does that mean? Well, we had a line break and now we've got water in the trench, or we got into a different soil type that is not nearly as stable. So we're going to bring our competent person out and have them look at what we've got going on and make some decisions around it. Okay, just before we wrap up here, what happens if we have a collapse? Somebody gets buried in a trench. They're buried up to their ankles or their knees. This is an emergency just as much as somebody buried over top. We need to make our phone call right now, 911. It's going to take time to get the resources out there to do this, just like confined spaces. Most fire departments don't have all the stuff to do this, and it's going to take time to bring those resources there. So we've got to make that call as quick as we can. If somebody's buried, but we can see where their tools are, leave the tools where they are. That's going to help us identify where people are. Let's account for our people. Part of the, on the confined space permit, we're going to account for all of the people that we have there, because when bad things happen, sometimes was Joe in there? I don't know. And we're trying to figure out where our bodies are, where are our people. So do those things, but I don't want you guys responding to trench collapses. I want you guys doing things right to start with. That means having our shielding in place, having that trench box available, inspecting these trenches every time. Going back to the confined spaces, do it right every time. Test and ventilate. Have people tied off so we can get them out. These are essential parts of doing your job. There's no job so important. There's nothing that has to be done so quickly that we don't have the time and resources to do it safely. And back up, let's back up and determine what we need to do this safely. Don't put your life at risk for a ditch. Let's do this right each and every time. Okay, I went just a little bit over, just a few minutes, which I'm pretty impressed with. Mike, do we have any questions out there? Folks, if you've got questions, comments, type those into the chat box and we'll answer those now. What do we got, Mike?
You must have done an amazing job, because we don't have any questions.
I'm sure it was an amazing job. There's a few things that I was just thinking about that I didn't hit quite as hard as I should have. I didn't talk about tripods and some specifics on that. But if you've got some questions about these things, I know this is a long session for a Zoom meeting. So we'll wrap up if we don't have other questions. But if you have questions, if you don't have a confined space meter, and you need to get that kind of stuff, give me a call. There's no judgment here. If you've got issues, you've got concerns about stuff. Hey, we need a meter, or our meter hasn't been calibrated for 3 years. How do I make sure it's done? Give me a call. 435-213-6869. That's my cell number. You give me a call, and let's make sure that we're doing it safe. All right, Mike, anything else?
Just a lot of thank you.
Thanks.
A lot of thanks, Jason. Nice job. Thank you.
Really appreciate all of your work out there. You don't get enough kudos and enough thanks for keeping the water running, keeping the sewer going, keeping the electricity, and whatever it is that you guys are doing out there. I appreciate it. It's important work to keep our communities, and you're making life better out there. Let's take the time to do it right and safe, so we can have those good careers and then enjoy that URS retirement and not have those bad accidents happen. Love to answer any questions you have. Everybody, go out and have a safe day. Thanks so much.
Yeah, the question is asked if this will be recorded. Yeah, and you can get a copy. Yeah, you can get a copy on the Trust YouTube channel.
yeah, so I'll send out the documents that we that I mentioned in there, but I did record the session, and I will get it all edited and rendered, and hopefully it'll be up on the YouTube channel later this afternoon. Everybody that signed up will get an email when it goes live there, along with those documents. And when you go to YouTube, you can even do it right now. Go on there and subscribe to the channel. There's tons of stuff. If you know, the boss says, hey, you're in charge of the safety meeting today, just dive right into that YouTube channel there, and there'll be something there to help you out. So awesome, guys. Thanks so much. Go out and have a safe day.